A student is given two test tubes and is told that one contains an aqueous solution of sodium chloride, while the other contains an aqueous solution of barium nitrate. Which precipitating reagent, if added to both test tubes, would allow the student to determine their contents? A. Aqueous silver nitrate. B. Aqueous potassium sulfate. C. Neither. Or D. Both. A common way to differentiate solutions containing different ions is to add reagents that will cause precipitation in one but not the other. To predict if precipitation would occur, we use the solubility rules. Let's examine choice A. What would happen if when we add silver nitrate to the two given solutions? If we were to add silver nitrate solution to the sodium chloride solution, we would expect a precipitate to form. Why? The solubility rules for common ionic compounds tell us that silver chloride is insoluble in water. Therefore, silver ions from silver nitrate will combine with chloride ions from sodium chloride and yield a precipitate of silver chloride. This is the only precipitate we expect to get from this mixture. The solubility rules tells us that compounds of sodium and nitrate ions are soluble in water. What about the barium nitrate solution? If we were to add silver nitrate to it, we don't expect to observe precipitation. The only anions present in the resulting mixture are all nitrate ions. The solubility rules tells us that compounds of nitrate ions are soluble in water. This means that silver nitrate will allow us to distinguish the two solutions. NaCl will yield a precipitate when mixed with silver nitrate, but barium nitrate will not. Therefore, choice A is a possible answer, and choice C is obviously not a correct answer. Now let's examine choice B. If we were to add potassium sulfate to sodium chloride, we do not expect to get a precipitate. Why? Solubility rules tells us that compounds of sodium and potassium are soluble in water. We do not have a cation that can precipitate out of this mixture. However, if we add potassium sulfate to barium nitrate, we expect to get a precipitate of barium sulfate. Solubility rules tells us that weak compounds of potassium and nitrate ions are soluble in water. Therefore, we cannot expect a precipitate to form from nitrate ions or from potassium ions. However, solubility rules tells us that although most sulfate are soluble in water, barium sulfate is an exception. Therefore, we would expect barium ions from barium nitrate to combine with sulfate ions from potassium sulfate to yield a precipitate of barium sulfate. Therefore, potassium sulfate will also allow us to differentiate between the two solutions. It will not produce a precipitate with sodium chloride, but it will produce a precipitate when added to barium nitrate. Since both A and B are possible answers, the best answer for this question is choice D, both. Here's a review of the solubility rules for common ionic compounds. Note that compounds containing sodium, potassium, and nitrate ions are always soluble. Chlorides, on the other hand, are generally soluble, but silver chloride is an exception. Sulfates are also generally soluble, but barium sulfate is an exception.